Welcome to the next session, my dear friends. So in the previous session we have discussed up to the question number 13. So in this session we are going to discuss the subsequent questions of the previous gate. So question number 14. Question number 14. It is GATE 2013 2 marks question. GATE 2013 2 marks question. So let us read out the question first. So the question is, a settling tank is designed for a surface overflow rate of 30 meter cube per day per meter square. Assuming specific gravity of sediment particles is 2.65, density of the water is 1000 kg per meter cube, dynamic viscosity of the water is 0.001 Newton second per meter square, and Stokes law is valid. The approximate minimum size of the particle which can be completely removed. So this is the question. Okay, so again the same concept. What is the given data? Given data, first one is the surface overflow rate. Okay, surface overflow rate V0, surface overflow rate V0 is equal to 30 meter cube per day per meter square. Meter cube per meter square, that is surface overflow rate. And a specific gravity S is equal to 2.65. Specific gravity S is equal to 2.65. Density of the water gamma W. Density of water gamma W. Density of water gamma W 1000 kg per meter cube. Kg per meter cube. And dynamic viscosity. Dynamic viscosity is equal to 0.001 Newton second per meter square. 0.001 Newton second per meter square. So the approximate D. So what is the diameter that can be removed? What is the diameter that can be removed? So minimum size of the particle means what? It indicates that 100% efficiency. Minimum size. So here what is saying? The approximate minimum size of the particle which can be completely removed. Okay. So completely removed means what? Completely removed means efficiency is 100%. Efficiency is 100%. Okay. So that is given here. So for this efficiency, what is the diameter of the particle? What is the diameter of the particle in mm? In mm. Okay. So first of all, convert all of them into same units. Eta efficiency means what? It is equal to Vs by V0 into 100. So that implies Vs is equal to V0. Vs is equal to V0. This is the relationship it was given. So V0 is given. So what is the value of V0? It is 30 into meter cube. So day, convert this into seconds. 24 into 60 square. Okay. So meter square per second. So it is nothing but some value will come, that is in meter per second. And here here mu of water is given in Newton second per meter square and gamma W is given in kg per meter cube. I already told you. So nu kinematic viscosity is equal to dynamic viscosity by density. So the dynamic viscosity, if it is in Newton seconds per meter square, is this value, then this is equal to 0.0001 kg second per meter square. Okay, kg second per meter square. Now, so mu is 0.0001 kg second per meter square by, okay, so it is 1000 kg per meter cube. It is, I think, kg second per meter. Okay, so this will be equal to 3 zeros, 30, that is equal to 10 to the power of minus 6, 10 to the power of minus 6 meter square per second. Meter square per second, that is the kinematic viscosity. This is the kinematic viscosity. Now we know that Stokes law, V is equal to G by 18. Vs is equal to G by 18 into S minus 1 into D square by nu. Okay. So G, what is the value of G? 9.81 meter per second square into what is the specific gravity? Specific gravity 2.65. So 2.65 minus 1 d square in meter I will get, meter square. Okay. So by 18 into, so this is also in meter square per second, 10 to the power of minus 6 meter square per second. Okay. So this will be Vs in meter per second. And here also we will get the value in meter per second. Okay, 30 by 24 into 60 square. So if you do that, we will get a V naught as 3.47 into 10 to the power of minus 4. 3.47 into 10 to the power of minus 4. (30 by 24 into 3600). 3.47 into 10 to the power of minus 4. So this is meter per second. Okay. So now equate V naught and Vs. Equate V naught and Vs. Then we will get the value of D. We will get the value of D as, so by equating 3.47 is equal to, by equating these two, 3.47 into 10 to the power of minus 4, that is V naught, is equal to 9.81, okay, into 1.65 d square by 18 into 10 to the power of minus 6. This is Vs. This is also in meter per second. This is also in meter per second. So if you equate these two, then you will get D value. Okay. If you solve that equation, we will get the D value as 1.96 into 10 to the power of minus 5 meter. 1.96 into 10 to the power of minus 5 meter, which is nothing but 1.96 into 10 to the power of minus, so 0.0196 mm. Approximately it is equal to 0.02 mm. Approximately it is equal to 0.02 mm. Okay, so everywhere the formula is same. If you see all the previous GATE examination questions, the formula is same. Only thing is unit conversions and numerical conversions. That is the only thing we are doing here. Okay. Let us go to the next question. 2014 2 marks set 2. 2014 2 marks set 2. Question number 15. Question number 15. So almost every year we are getting a 2 marks question from this concept, and that too a very easy concept from the same formula. Again and again they are asking. So that is why environmental engineering and geotechnical engineering, these two subjects are very scoring for GATE, because the questions which they ask will be very simple and repeated. If you put less effort, we can get more marks with less effort. That is why these two subjects are very, very important for GATE. Okay, next question, question number 15. A suspension of a sand-like particles in water with particles of diameter 0.10 mm and below is flowing into a settling tank at 0.10 meter cube per second. Assuming G is equal to 9.81 meter per second square, specific gravity is 2.65 and kinematic viscosity is 1.0105 into 10 to the power of minus 2 centimeter square per second. The minimum surface area required for this settling tank to remove the particles of size 0.06 mm and above with 100% efficiency. So this is the question. Okay, let us extract the data required for us. So the given data, a suspension of a sand with the particles of diameter. Okay, so generally the suspension is going with the particles of diameter. So particles diameter is given as particle dia d is given as 0.10 mm. So this is a normal diameter of the particle which is present in the suspension. Okay, a suspension of a sand-like particles in water with particles of diameter 0.1 mm and below. Okay, particle dia d 0.1 mm and below is moving through the water. Okay, and the water is having a rate of flow. Okay, the water is having a rate of flow that is Q, which is equal to 10 meter cube per day, 0.10 meter cube per second, 0.10 meter cube per second. So this is the rate of flow. Rate of flow is given, and assuming G, acceleration due to gravity, G is equal to 9.81 meter per second square, and kinematic viscosity is given as 1.0105 into 10 to the power of minus 2 centimeter square per second. Okay, centimeter square per second. The minimum surface area, so he is asking the area of surface or simply plan area. Plan area A is equal to how much? The plan area or surface area is equal to how much? Okay, so to remove a particle, so efficiency, with an efficiency of 100%, so diameter to be removed, the minimum dia to be removed is 0.06 mm. So though the water is containing particles having diameter 0.10 and below, but this settling tank should remove the minimum diameter of 0.06 mm and above with 100% efficiency. So up to 0.06 mm. So it should remove with 100% efficiency. So this is the boundary condition for 100% efficiency. So efficiency is 100%. So if efficiency is 100%, it indicates what? So Vs is equal to V naught. Okay, Vs is equal to V naught at D is equal to, at D minimum is equal to 0.06 mm. So at this case condition, Vs is equal to V naught. Okay, now so here Vs we can find using the given data. So what is Vs as per the Stokes law? Vs is equal to G by 18 S minus 1 D square to nu. So what is G here? 9.81 meter per second square. Okay, this is S. Specific gravity is how much? Specific gravity is given. So specific gravity is 2.65. Specific gravity S is equal to 2.65. So 2.65 minus 1. 2.65 minus 1 into D minimum. What is D minimum? That is 0.06 into 10 to the power of minus 3 meter whole square. This is meter square. Okay, by what is 18? What is nu? Nu is given in centimeter square. We need to convert this into meter square. That is 1.0105 into 10 to the power of minus 2. So centimeter square means 1 centimeter is equal to 10 to the power of minus 2 meters. So 10 to the power of minus 2 into 10 to the power of minus 2. That means 2 centimeters are there. That is, it is equal to 10 to the power of minus 4 meter square per second. Meter square per second. Okay. So 1.0105 into 10 to the power of minus 6 meter square per second. So everything I have converted into same uniform units. Now I will get Vs in meter per second. I will get in meter per second. I will get. So what is the value of Vs in meter per second? Vs is equal to 3.204 into 10 to the power of minus 3. 3.204 into 10 to the power of minus 3 meter per second. Okay, so this is Vs. Now this Vs is equal to V naught, right? Vs is equal to V naught. So this is also V naught. So V naught is equal to 3.204 into 10 to the power of minus 3 meter per second. Okay. Now we know that surface area. He is asking plan area or surface area. Surface area A is equal to Q by V naught. Surface area A is equal to Q by V naught, where Q is 0.10 meter cube per second. So V naught is this one, 3.204 into 10 to the power of minus 3 meter per second. So solving this, we will get the plan area. Solving this, we will get the plan area as 31.214 meter square. 31.214 meter square. 31.214 meter square. 31.214 meter square. Okay. So this is the solution of the question number 15. Question number 15, GATE 2014, 2 marks, set 2. Let us go to the next question. Question number 16. Question number 16. Question number 16. GATE 2015, 2 marks. GATE 2015, 2 marks, set 1. Question number 16. Okay, so let us read out the question. Consider a primary sedimentation tank in a water treatment plant with surface overflow rate 40 meter cube per meter square per day. The diameter of the spherical particle which will have a 90% theoretical removal efficiency in this tank is dash micrometer. So he has given the efficiency. With this efficiency, what is the minimum diameter we can remove? Okay, so another data, assume the settling velocity, all the required relevant data is given. Okay, so let us extract the data given that a primary sedimentation tank surface overflow rate is given. Surface overflow rate V0 is equal to, surface overflow rate V0 is equal to 40 meter cube per meter square per day. So this is V0. This is V0 and the efficiency is 90%. Efficiency is 90%. And assume the data for Stokes law. Density of water, so rho W is 1000 kg per meter cube, 1000 kg per meter cube, and density of particle, so rho S, density of particle is 2650 kg per meter cube. Okay, and density G is given as 9.81 G, 9.81 meter per second square, and kinematic viscosity is given. The kinematic viscosity is given as 1.10 into 10 to the power of minus 6. 1.10 into 10 to the power of minus 6 meter square per second. Okay, these are the data. This is the data given, and he is asking for this efficiency. What is the dia? The minimum dia removed in micrometer. He is asking it in micrometer, not mm, not meter, micrometer he is asking. Okay, okay, so let us start. So efficiency is given as Vs by V0, which is equal to 0.9. Okay, so let us first find Vs. So Vs, that means Vs is equal to 0.9 times of V0. Okay, 0.9 times of V0. So what is V0? This is V0. So 0.9 times of 40. So let us convert this into meter per second. Let us convert this into meter per second. So meter square, meter cube will get cancelled and meter will present. This day I need to convert it into seconds. So 24 into 60 square. If I divide this, then it will become meter per second. So this is the value of Vs in meter per second. So this is the value of Vs in meter per second. So what is the value of Vs? What is the value of Vs? It will be equal to, so let us keep it aside. Let us keep that aside like that only. Let us start finding Vs from the Stokes law point of view. So this is from the efficiency point of view, we got the Vs as this. So from the Stokes law point of view, okay, using Stokes law, Vs is equal to G by 18 into, here it was given kinematic viscosity, so S minus 1 d square by nu. See, S is nothing but rho S by rho W. Rho S by rho W, again it will become 2.65 only. Again it will become 2.65 only. G, what is G? 9.81 meter per second square. And this is S minus 1 is 2.65 minus 1. 2.65 minus 1, because 2650 by 1000, it is a specific gravity. 2650 by 1000 is a specific gravity, which is equal to 2.65. So S value is 2.65. 2.65 minus 1, that is 1.65. 1.65 into D, I don't know. I will take it in meter square. Okay, by 18. What is the nu? Nu is 1.10 into 10 to the power of minus 6 meter square per second. So dividing this, we will get the unit of Vs in meter per second. So equating this 1 and 2. So 1 is also settling velocity and 2 is also settling velocity. Equate 1 is equal to 2. So that means this is equal to 0.9 to 40 by 24 into 60 square is equal to this 9.81 into 1.65 d square by 18 into 1.1 into 10 to the power of minus 6. From here we will get d in meter. So we will get d in meter, right? So both are in meter per second. So we will get the value of d in meter. So which is equal to, okay, which is equal to 2.258 into 10 to the power of minus 6 to 10 to the power of minus 5 meter. 10 to the power of minus 5 meter. Okay, 2.258 into 10 to the power of minus 5 meter. So if I want to convert this into micrometer, that means 22.58 into 10 to the power of minus 6. I can write this as 22.58 into 10 to the power of minus 6 meter. So 10 to the power of minus 6 into meter is nothing but micrometer. 10 to the power of minus 6 into meter is nothing but micrometer. So it is 22.58 micrometer. Okay, this is the answer. 22.58 micrometer is the minimum diameter that can be removed at an efficiency of 90% for this given data. Okay, so let us go to the next question. Question number 17. Question number 17. Question number 17. GATE 2016. 1 mark set 2. 1 mark question set 2. GATE 2016. (16) 1 mark set 2. So question number 17. So let us read the question. A water supply board is responsible for treating 1500 meter cube per day of water. A settling column analysis indicates that an overflow rate of 20 meter per day will produce satisfactory removal for a depth of 3.1 meter. It is decided to have two circular settling tanks in parallel. The required diameter, diameter expressed in meter of the settling tanks is, here what is the given data? What is the given data? So given data, given that a water supply board treating a water, so rate of flow is given. So rate of flow Q is equal to 1500 meter cube per day. The rate of flow is 1500 meter cube per day. A settling column analysis indicates a overflow rate. So overflow rate is given, overflow rate, that is V naught. V naught is how much? 20 meter per day, 20 meter per day, okay. And so here it will produce satisfactory removal for a depth is given. So depth h is equal to 3.1 meter. Depth h is equal to 3.1 meter. So it is decided to have two circular settling tanks, okay. So we are providing two circular settling tanks. We are providing two circular settling tanks, the required diameter. So here we will get the surface area first. We need to, before calculating the diameters of the circular settling tanks, we need to first find the surface area, okay. So total surface area required is equal to total surface area required is equal to Q by V naught. Okay. So it is 1500 meter cube per day. So this is 20 meter per day. So it is nothing but 75 meter square. This is total surface area. Now we are providing two circular tanks. So each circular tank area is equal to 75 by 2, that is 37.5. Each tank area is 37.5 meter square, okay. So if you take approximate value, generally if we are calculating the volume of a circular tank, if you are taking volume of a settling tank, circular settling tank, so it will be a different value. Because in circular sedimentation tank there will be conical portion. Also. We need to calculate the conical portion also into account while calculating the volume of the circular sedimentation tank. So what is the volume of the circular sedimentation tank including the conical portion? The volume is d square. Into 0.785 H plus 0.785 H plus 0.011 D. Actually this is the actual volume formula, okay. So 37.5 is the volume. So 37.5 is equal to d square to 0.785 to depth is given, that is 3.1 plus 0.011 D. If you solve this equation, quadratic equation, so it will become little lengthy, okay. So generally we can also approximate it, okay, by simply taking it as circular area, pi d square by 4. So if you take directly pi d square by 4, so pi d square by 4 is equal to 37.5. So d is equal to square root of 37.5 into 4 by pi. So this is an approximate formula. From here we will get this d as 6.9. We will get it as 6.909. So this is an approximate, but this is the exact formula we need to use to find the diameter of the diameter of the circular tank. Okay. So now let us go to the next question. Question number 18. Question number 18, 2017, 2 marks. Set 1, 2017. So every year we are getting one question, 2 marks or 1 mark from this concept. (18) 2017, 2 marks. Question number 18. The spherical grit particles having a radius of 0.01 mm and a specific gravity of 3.0 needed to be removed separately in a settling chamber. It is given that G is equal to 9.81 and the density of the liquid in the settling chamber is 1000 kg per meter cube and the kinematic viscosity is 10 to the power of minus 6 meters square per second. Assuming laminar conditions, the settling velocity is mm per second up to 1 decimal. It is a very simple question, but it was asked for 2 marks. Okay, so given data, given that here the radius of the particle, radius is given. So radius R is equal to 0.01 mm. That means D is equal to 0.02 mm. So many people will do mistake here. They will directly take R as diameter and do the question. So but here it is radius of the particle. So diameter is double of the radius, which is equal to 0.02, and the specific gravity, say specific gravity S is given as 3.0. S is given as 3.0 and G is 9.81 meter per second square, and the density, so rho W is 1000. So rho of water is taken as 1000 kg per meter cube, 1000 kg per meter cube, and the kinematic viscosity nu is taken as 10 to the power of minus 6 meter square per second. So he is asking what? Settling velocity is how much? Simple question. Settling velocity is how much in mm per second? Mm per second. So Vs is equal to Z into S minus 1 d square by 18 nu. So Z is given as 9.81 in meter per second square into S is 3. 3 minus 1. D is given as how much? 0.02 into 10 to the power of minus 3 whole square. This is in meter square. And 18 nu is in meter square only, 10 to the power of minus 6 meter square per second. Now the value of this will come in meter per second. So meter square cancel, second cancel. So we will get the value of it in meter per second. So what is the value of it in meter per second? Question number 18. What is the value of it in meter per second? It is 4.36 into 10 to the power of minus 4. 4.36 into 10 to the power of minus 4 meter per second. So but here it is asking in mm per second. So 0.436 mm per second. So 0.436 mm per second is the velocity, settling velocity. Okay, that is the settling velocity. This is question number 18. Question number 18. So we will discuss the rest of the questions in the next class. So this is for this session. We will discuss the questions from 19 onwards. in the next sessions. Okay, thank you.